Okay, so the streaming is working now. So, hello everyone, you're welcome to this exam of Mr. Felipe González-Pizarro, which is opting to the Master in Science on Informatic Engineering here in the Universidad Técnica Federico Santa Maria. The evaluation committee is composed by Dr. Evangelos Milios from Dalhousie University, Professor Claudia Lopez from the Universidad Técnica Federico Santa Maria, Department of Informatics, and myself, Marcelo Mendoza, as an internal evaluator and also presiding this committee. Felipe will have with this thesis that is entitled TopicVisExplorer, Supporting Multi-Corpora Comparison through Visual Exploration of Topic Modeling, an exam with 3 parts. The first part is the presentation of the project and the results, and then we will have the oral exam with some questions from the evaluation committee, and finally the third part corresponds to the qualification of the exam. So for the first part, we will have approximately 30 to 35 minutes. Yeah. So please, Felipe, try to fit the time.
That's the most difficult part.
Okay, just try to do your best. So, now we will start with this first part. So Felipe, you have the token.
Okay, so thank you so much for the presentation. So as Professor Marcelo said, my thesis is TopicVisExplorer, supporting multi-corpora comparison through visual exploration of topic modeling. So today there is a large scale of textual data, and for that reason, it is really important to create or to design algorithms that allow us to understand or summarize this information. And one of these promising solutions is topic modeling, which is a statistical approach for extracting topics from large corpora. Topic modeling algorithms are really powerful, but they do not provide meanings and interpretation directly. And for that reason, humans must be involved. Humans who interact or must interpret the results of these algorithms can use visualization tools to better interpret the results. So this slide provides a clear example about how topic modeling visualization tools can be useful. Here in the left, you can see a raw output of a topic modeling algorithm. Each list is a list of keywords that represent a topic. In the right, you can see a similar result using a topic modeling visualization tool. In this case, each topic is represented by a circle, and the position in this 2D layout represents the similarity with other topics. When a user clicks one of these topics, and the user can see in the right the more relevant keywords associated with that. So during the last year, many tools have been designed to help users interpreting topics. However, finding mechanisms to improve this visual representation is still an open challenge. There are several problems. So one of the things that people or users must deal is with poor quality of topics. So sometimes the result of these algorithms are not very good because topics are noisy or are incoherent, or they are not aligned with the domain expert understanding of the corpus. And previous research showed that when users apply topic refinement operations such as merge topic or split topics, they can improve the results. Indeed, users prefer interfaces that allow merging and splitting of topics. While these operations are important, there is a scarce support for topic merging and topic splitting. And those visualization tools that allow users to merge a topic have some limitations. First, during the process, they do not consider the relevance of all the keywords and all the documents associated with topics. Therefore, the performance is limited sometimes. And also there is a scarce number of user evaluation. Therefore, the implication about how users use this functionality is not yet well understood. In the case of visualization that support topic splitting, and they do not support LDA, which is a topic modeling algorithm that is really traditional and very powerful and very popular. And also in the case of these algorithms, the splitting of topics is based only on the most relevant keywords. So the problem here is that when keywords of a topics are noisy, are poorly connected, or incoherent, the results are not very good. And when users face this problem, they feel frustrated when the news of topics are not very meaningful. Also, there is a problem regarding with a scarce support for multi-corpora comparison. So only a few of the topic modeling visualization tools allow users to compare 2 or more topic models. And those who exist, again, do not support LD8. And as I said before, that is a really popular traditional algorithm. All these visualization must use a topic similarity metric to allow to the user estimate or identify the topics that are similar between 2 datasets. And the problem with this metric is that all of them model the topics as a ranking list of terms. And here we face the same problem that before. So when this keyword or these terms are noisy, poorly connected, or incoherent, the performance is affected. So in a nutshell, current visual representations allow to refine and compare topics based only on their more relevant keywords, leading to poor performance when these terms are too generic, poorly connected, and do not provide enough information. To address some of the limitation of previous tools, in this thesis, I designed, developed, and evaluate TopicVisExplorer, a set of web-based interactive visualization of LDA-generated topics. This thesis, or TopicVisExplorer, supports users during topic refinement and comparison. And in this thesis, there are 3 key innovations. First, I propose a topic merging algorithm that considers the terms and documents of 2 independent topics. Also, I propose a new document-based topic splitting algorithm, and I propose a topic similarity metric that estimates the similarity between topics considering the more relevant keywords and the more relevant documents. TopicVisExplorer contains 2 layouts. The first one you can see here in this slide, and this layout contains 4 components. The first one in the center, you can see a global view of the topics. Each topic is represented by a circle, and their position in this 2D layout indicates the similarity with other topics. Topics that are more similar appear closer. When a user clicks one of these circles, the user can see the more relevant document associated with that in the right, and also can see the more relevant keyword associated with that topic in the left. This layout also has some buttons that allow users to perform merging of topics or topic splitting. So when user want to merge a topic, the user have to select the topic, then click the button merge topic, and then a model view is going to appear when the user has to select the other topic that want to use to finish the operation. And then the visualization is going to be adapted accordingly. So in the background, TopicVisExplorer adds together the probability distribution of words of 2 independent topics, and do the same with the probability distribution of these topics in all the documents. Then calculates the new frequency of the merged topic and estimates similarity between this new merged topic and the other topics. In the case of the topic splitting, so TopicVisExplorer allows users to split a generic topic into 2 new subtopics. And here is different than previous tool because when a user wants to do that, they have to select the topic, go and click the splitting button, and then a model view is going to appear as you can see here in this slide. So in this model view, the user can read all the documents associated with that topic. And I ask to the user to categorize this document in 2 new categories: those who are related with the news at topic A and those who are related with the news at topic B. The user do not have to categorize all the documents, and for that reason, TopicVisExplorer are going to perform or run an algorithm to categorize the uncategorized documents using word embeddings and cosine similarity between the vectors created from these items. So as a second layout, TopicVisExplorer also provides an interface that allows users to compare 2 topic models, this can be really helpful when users, for example, must compare two different data sets. So this layout contains 3 components. In the center, you can see an overview of the relationship between topics. So here, each topic is represented as a box, and the color of the box indicates the dataset. So topic from the dataset 1 appears in the left with color blue, and topics from the second dataset appears in the right with the color red. The paths or the links that connect those boxes indicate the similarity between them. So topics that are more similar appear with a wider link. Here, this is a Sankey diagram, so user can use a slider to filter the links, and in this way, the user can see all the links that contains a similarity score higher than a specific threshold. Okay, so here also when a user clicks one of the topics into the left, for example, one of the blue topics, blue boxes, and the information related with that, the more relevant keywords and the more relevant documents are going to appear in the left panel. This thesis also proposed a new topic similarity metric based on word embeddings, and this metric considers the more relevant keywords and the most relevant documents to perform the comparison of topics. For that reason, it contains several components. Each topic is represented by a vector, set sub k, and this vector is actually composed by other 2 vectors, x sub k and y sub k. So x sub k is actually a vector that represents the contribution of the top n words of a topic k, and the vector y sub k is a vector that represents the top n documents weighted according to the contribution delta to the topic k. So the balance between these 2 vectors that represent the more relevant keyword and that one that represents the more relevant documents is given by a omega parameter, as you can see here in this equation. So having all the vectors that represent all the topics, I apply cosine similarity to identify similarity between the topics. So the results can change when we use a different omega. For that reason, TopicVisExplorer also supports users to explore different results, changing the omega parameter using the respective slider in the first layout and the second layout. So as I said before, few topic modeling visualization tools allow users to refine topics, and most of them have not been tested with non-expert users on real-world scenarios. Therefore, the implication about how these functionalities affect the user experience are not yet well understood. Also, a few topic modeling visualizations allow users to compare at the same time 2 topic models, and there is no evidence about the user performance while finding similar topics among 2 datasets, and there is no information about how topic similarity metrics impacts the user experience in realistic scenarios. And for all this reason, in my thesis, I conducted a user study. So TopicVisExplorer contains operations to merge topics and split topics. And it is expected that when users apply those operations, they can adjust the model to their needs and also improve the initial model. And one way to measure if the model was improved or not is by using coherence metrics. So coherence can be self-reported by the users. The user can say how coherent each topic, and also there are automatic way to measuring coherence. For that reason, the first null hypothesis that I tested in this thesis is the following. There are no difference in the coherence of topics between people who apply TopicVisExplorer's mechanisms for topic splitting and topic merging and people who do not. Regarding with the comparison of topics, as I said before, the current topic similarity metrics are based only on keywords. Therefore, when these keywords are noisy, poorly connected, or incoherent, the performance of this metric is not good, and they can establish matches between topics with ambiguous terms. So it is expected that if we add another level of information, such as the more relevant documents, to those metrics, we could achieve better performance. For that reason, in this thesis, I also tested the following null hypothesis. There are no difference in the performance and error rate when comparing topics between people who use a topic similarity metric based on keywords and documents, and those who use a keyword-only similarity metric. I conducted a between subject user study. For this purpose, I recruit computer science students without any knowledge of topic modeling. All these users or participants were divided randomly into groups, the experimental group and the control group, and the user study contained two scenarios. In the first scenario, I asked the user to identify topics from a dataset using the first layout of TopicVisExplorer. In this case, the experimental group was allowed to apply topic splitting and topic merging. The baseline group in this scenario couldn't apply those operations. Then, in the second scenario, I asked users to identify matches between topics from two different datasets, and using the second TopicVisExplorer layout. In the case of the experimental group, they completed tasks using the proposed topic similarity metric, while the baseline group completed tasks using a topic similarity metric of the state of the art. So this slide shows more information about how the user study was conducted. So I used two methods to collect the data: a SurveyMonkey questionnaire, where I collect, for example, the raw NASA TLX score. And this questionnaire allowed me to identify the workload of the user after completing the task. So for example, how demanding was the task, or how many effort were required to do or to complete each scenario. I also use JavaScript to collect secondary information, for example, the task completion time. In the first scenario, the user labeled the topics of the European dataset that I will explain in the next slide. And for each topic, they report the coherence, so how coherent each topics, and they report the workload after applying this task, and then after completing this task, and then they submit the results. In the second scenario, they label the topics again, they identify matches between the two datasets, and again, they reported the workload, and they have to submit the results. So for this user study, I use a Facebook Cambridge Analytica dataset that contains English tweets collected during 2018 using keywords or hashtags related with the Facebook and Cambridge Analytica scandal, such as delete Facebook, Zuckerberg, Facebook privacy. This dataset contains two collections, one related with one is the European subset that contains tweets from European users, and the other one is North American subset that contain tweets from North American users. Here in this slide, you can see the different topics that are found. For each subset, I apply LD8 with number of topics equal to 6. And here you can see the name of each topic and the more relevant keywords of each one. The complete list of topic terms and documents appear online. Before the user study, I conduct a pilot user study. And then after evaluating the user in the real user study, I asked them to complete an interactive tutorial. So in this tutorial, the user learned how each component of TopicVisExplorer works. For that reason, you can see some description about each component. Also, I must have said that evaluating topic similarity metric is really challenging because there is no a threshold, a specific threshold regarding whether a topic is or is not related to another one. Actually, it's highly suggested. And for that reason, I designed several methods to evaluate the performance and the error rates of the proposed topic similarity metric. First, I asked 3 annotators who didn't participate in the real user study to identify matches between the European and North American subsets. With their answers, I create a strict grand truth, which actually is the intersection of their answers, and a moderate grand truth, which is a union of their answers. I also create a way to identify errors during the comparison of topics. So errors are matches between topics that do not share a semantic relationship. And here in this slide, you can see that actually the cells without a green color indicate topics that do not match at all. After every evaluation, I use different, in each evaluation, I use different statistical methods to identify the relationship between independent variable and dependent variable, and I use Python and R to complete this task. Now let's explore the findings. So as I said before, in the first scenario, I asked user to identify the topics of the European subset using the first layout of TopicVisExplorer, as you can see here in this slide. And the experimental group performed this operation applying topic splitting and topic merging, and the baseline group couldn't apply those operations. So I invite 120 users or participants or people to the user study, and around 80% of them agreed to participate. Then I remove answers from people who didn't complete the SurveyMonkey survey or who didn't submit the results, the final result, the final topic model. And also in the case of the experimental group, I remove people who didn't apply topic splitting or topic merging. And then I remove outlier regarding with the task completion time. So the results showed that actually there are no significant difference regarding with the number of levied topics between the baseline and experimental group. However, the time is different between them. People from the baseline group require less time compared with people from the experimental group to complete the first scenario. Also, I identify the percentage of users from the experimental group who apply a topic refinement operation by topic. And I found a significant difference in these proportions. So the percentage of users who apply a topic splitting or topic merge operation over topic E2, E3, and E5 are significantly larger compared with the other topics. These topics are highly related with the data privacy scandal. In the opposite is found regarding with the topics E4 and E6. So here the percentage for users who apply a topic refinement operation over these topics is significantly lower. And these topics are not highly related with the scandal, especially the topic E4 that actually is related with big data and artificial intelligence. So the result showed or suggests that participants prefer to apply topic refinement operations in topics more related to the Facebook and Cambridge Analytica scandal. To further analyze the results, I also identify the coherence of each topic using automatic coherence metric. And I found significant difference in these scores. So actually compared with other topics, the coherence score for the topic E4 is significantly higher. And this is the same topic that no one applied a topic refinement operation over it. So the results hint that TopicVisExplorer functionalities can help users to identify topics that need further refinement. So using a generalized linear mixed effective modeling approach, controlling by participant and topic, I compare the coherence reported, the self-coherence reported by users between the baseline and experimental group during the first scenario. And I didn't find any statistical difference between this group. Therefore, I cannot reject the null hypothesis A. However, I said before that one way to measure the coherence is by asking to the users and also using coherent metrics. So in this case, this slide shows the following. The experimental group had an initial topic model. They applied topic refinement operation, topic splitting, and topic merging. So at the end, they modified that model to their needs. And then I apply 4 different coherent metrics to identify or to evaluate if the result or the final output was better than the initial or worse. And actually, some of them achieved a better coherence score and other people didn't. So when we talk about all these automatic coherence metrics, between 40 and 60% of the participants improve the coherence scores. So the results show that non-expert users can improve the quality of the initial topic model using topic splitting and topic merging. Or to further analyze the results, I divide the experimental group in 2 groups: those who achieve a higher coherence score than the initial, and those users who didn't improve the initial topic model. And then I compare the percentage of users who apply a topic reform operation by topic. So I found difference between these proportions. In the case of the topic E1 and in topic E6, the proportion of users who apply a topic reform operation over those topics was significantly larger in the user who achieve a higher coherence score. So the results suggest that depending on which topic nodes per user apply a reform operation, the overall coherence of the topic model change. As I said before, I use the NASA TLX questionnaire to evaluate the mental demand, physical demand, temporal demand, performance, effort, and frustration of the user after completing the scenario. And I didn't find difference between the baseline and experimental group. This is a positive result because, as I said before, in the case of the experimental group, they had to read all the documents or a high number of documents to perform the topic splitting operation. However, they didn't report a higher mental demand or physical demand or temporal demand after completing the task. So now let's move to the second scenario. In this scenario, I asked the user report matches between topics from two datasets, the European subset and the North American subset, using the TopicVisExplorer second layout. In this case, people from the experimental group use the proposed topic similarity metric, and participants from the baseline group use a metric of the state of the art to complete this task. Again, these are the same users that complete the first scenario. They were randomly divided again in the baseline experimental group, and I delete answers from people who didn't complete the SurveyMonkey survey, who didn't submit their final topic model, and also I detect and remove outlier regarding with the number of topics labeled and outlier regarding with the task completion time. So this slide shows the match between topics in the baseline group and experimental group. So there are 36 possible matches, and each cell shows the percentage of users who apply or identify those topics as a match. What it was interesting is that I didn't find difference between the distribution of number of matching between groups. However, as you can see here in the last figures, some topics are considered matches in one metric and not in another one. So that needs further discussion. So as I said before, it's really challenging to evaluate topic similarity metric because the threshold regarding whether a topic is or not related with another is highly subjective. So I designed a method, error ground truth, and I identified that the failure rate between the baseline and experimental group differs significantly. So while 30% of the users for the baseline group made at least one mistake, only 7% of the users from the experimental group did the same. In that case, or for that reason, I can reduce the null hypothesis B in terms of the error rate. I also evaluate the performance of the proposed metric and the baseline topic similarity metric regarding with precision and recall, comparing their answers with a moderate ground truth and a strict ground truth. In the case of the moderate ground truth, I didn't find difference regarding with precision and recall between baseline and experimental group. However, when we refer to the strict ground truth, I found that the precision score obtained for the experimental group were lower than those from the baseline group. So the ability to return only correct matches is lower in the proposed metric. And that means that actually there is some space for improvement in future research. For that reason, I can also reject the null hypothesis B in terms of the performance. And just to finish the results, I have to say that I also evaluate the workload perceived by user after completing the second scenario in terms of mental demand, physical demand, temporal demand, performance, effort, frustration. And I didn't find difference between the baseline and experimental group. Now, let's move to discussion and conclusions. So TopicVisExplorer can supports users applying topic reform operation and comparison of topics. And the user study showed that users can incorporate the semantics of a domain knowledge for topic model refinement without understanding the inner workings of the topic model. And this is really important because in this case, I completed the user study with non-expert users. So this was really interesting. In the first scenario, it was expected that users from the experimental group, after applying topic splitting and topic merging, they report higher coherence score of topics, higher topics coherence. But I couldn't find that. And there are many reasons that could explain that result. So first, non-expert users do not have preconceptions of how refinement operation might impact the topic model. And previous research also indicates that actually non-expert users sometimes can create a correlation that do not make much sense. For that reason, while topic modeling refinement operations are useful and powerful, there are still entry barriers for these users. So teaching the impact of this operation might help in future research. Also, the results show that topic refinement is context dependent. So we saw in the user study that some topics were not directly related to the data privacy scandal, such as the topic E4, which is actually related with big data and artificial intelligence, and no one applied a refinement operation over that topics. So users actually focus on topics more related with the privacy, with the data privacy scandal. So yeah, they apply operation related, for example, to the topic E3, which is Cambridge Analytica's data to manipulate political decisions. Regarding with the comparison of topics, I said many times before that it's really challenging to identify or to evaluate the performance of these metrics, and because there is the threshold regarding whether a topic is or not related with another one is highly subjective. So future studies should explicit the criteria that makes two topics match. For example, ask user match topics that rarely share distribution of words and documents. And also during this research, I deal with the absence of benchmark dataset for comparative evaluation between models. And for that reason, I had to design several evaluation methods in order to identify the performance and error rate of two similarity metrics. TopicVisExplorer supports users in refining during the topic refinement. So in this user study, participants recognize topics that need further refinement. Non-expert users apply topic merging and topic splitting operation to adjust the initial model to their needs. And some of them, actually around 60% of them, improve the automatic coherence of the topic model after applying those operations. Regarding with the comparison of topics, TopicVisExplorer support users comparing topics from one or two topic models. This comparative analysis of topic model is an open research challenge that has gained little attention so far, but this result showed that the proposed topic similarity metric can reduce the number of mistaken matches. And also it's useful when comparing topics generated from real-world large-scale datasets. As a result, non-expert users can benefit from visualization tools to compare topics model and an automatic metric that evaluates the similarity between topics, considering their most relevant keyword and their more relevant documents. As a future work, I expect to extend TopicVisExplorer to also allow users to use another topic modeling algorithms such as LDA2vec or NMF, and it would be a good idea, and I hope to do that soon, is to find options to visualize large number of topics in a complex manner. Just to finish, I have to say that during my master, I had the opportunity to also work in a different area. So I was working with my home teacher advisor in a computational thinking direction. One of the papers published on 2018 got the best paper award, and another journal paper is going to appear hopefully soon related with this area. As you can see here in this slide, I also have worked in this Facebook Cambridge Analytica scandal. So I had the opportunity to analyze tweets related with this data privacy issue and apply different NLP techniques. Just during this month, one of these papers was accepted in the Journal of Computer Supported Cooperative Work, which actually it makes me really happy about that. And I want to talk also regarding with paper published on 2019 in a workshop of the web conference, and the paper Global Reaction to the Cambridge Analytica Scandal, a cross-language social media study. In this paper, it was the first time that I used topic modeling to identify the topics from a large-scale dataset. And while I was doing this work, I realized how important it is to have a topic modeling visualization tools that allow me to improve LDA topics and also compare two different datasets. And this is the first stone, or actually it was the main reason from the beginning that inspired me to do this research. Finally, I want to say thank you to all the professors that have helped me during all this process. So thank you to Professor Claudia Lopez and Marcelo Mendoza from my home university, Universidad Técnica Federico Santa Maria. And I want to say also thank you to Professor Evangelos Milios and Fernando Pavlovich for all the supports again during all this process. I know that it was really difficult, especially with COVID times, but I'm really happy that we could finish the project. Now I am really happy and eager to hear your questions. Thank you.
Thank you, Felipe. Now we will start the second part of the exam, the oral exam. So we have some questions from the committee. We will start with the questions from Professor Evangelos Milios.
Thank you, Felipe. It was a nice presentation, and thanks for your kind words regarding your visit to Dalhousie. All right, so my questions are focused more on the text mining aspects of your research. And I would like to ask some detailed questions first. So the first question has to do with a mention in your thesis where you project the intertopic distances onto 2 dimensions. And my question is, what is the original dimensionality of the intertopic distances that necessitate the reduction to 2 dimensions?
Okay. Yeah, good question. Yeah, so actually in that case, what I do is after applying the topic similarity metric, the proposed topic similarity metric, I will have a matrix that contains I score. So actually, it's for example, we have 6 topics. It's going to be a matrix 6 by 6, where we can see the similarity between each topics. So in this case, I use cosine similarity, which reports a score between -1 and 1. And what it was important to do, and I had to deal with this, is how to project this matrix in a 2D layout here. So actually in the beginning, I tried, for example, use heat map to show the result of the topic similarity metric, but I realized that actually it wasn't very intuitive. So here you can see in this layout actually that something that it was based on previous research, and the name of that visualization is LDAVs, and in that case they use sorry, it's not PCA, it's really similar to PCA, but I forgot the specific name. But to transform that matrix in a way that we can get X and I position for each topics. So that allow me to make a transformation of those results. So I have a previous matrix with a score, and then I use something that is really similar to PCA. It's just one word that is really different, but allow me to change or to transform that matrix in this X and Y position. And also something that I did and I want to show is that I said that my metric also had the omega parameters. So I realized that when I change the omega parameters, I will go here because I put it in the here. Sorry. Give me 1 sec. Here. So I don't know if you can see here this slide. But in the beginning, when I did this transformation, I realized that when the people changed the omega score, the X and Y position of the topics changed a lot. So actually appear like in different places. So also I had to apply ProClusters, which is an algorithm to align two different matrices. And for the reason when the user here change the score little by little, you can see also a smoother transformation of their position between topics. Mm-hmm. So these are all the steps.
Great. Thank you. One of the contributions of your thesis is the introduction of a new metric, right, for comparing different topics. And I would like to ask you to explain the intuition behind this new metric in an intuitive way, okay, not through equations.
Okay. Actually, I just want to say that it was based on a previous work, and this is actually the topic similarity metric baseline that I use in the user study. So when I read this paper that was published in 2019, they proposed a novel idea about how to use word embedding in that case to represent the semantics of the more relevant keywords of a topics. So here they also create a vector that actually represent the semantics of a set of keywords. And then actually I use in a project and not rely on errors or some problem because this metric is not it's actually asymmetric. So it's not the same measuring the topics A and B than measuring the similarity between topics B and A. So that was really weird. and for that reason, it was a conflict for me. So for in that case, I realized that I shouldn't find a way to create a symmetric topic similarity metric. And I was really curious about how about how word embedding can help us to identify the semantics of keywords. So that's actually the core idea about that. So I wanted to represent this topic with a topic vector. And as I said in previous research, I realized that actually the keywords were not enough. And I deal with that when I did my project. So when I published my paper related with global reaction to the Cambridge Analytica scandal, I applied LDA, and I got a set of keywords for each topic, but I couldn't identify the meaning of the topic because many times appear, for example, the keyword Facebook. So Facebook appeared in the topic 1 and the topic 3 and the topic 5. And for me, it wasn't important, that keyword, because actually all the data were related with that scandal. So then I realized that I needed another level of information. So in that case, I manually read the most relevant documents. And with that, I could get a better idea about the semantics of the topic. And also then reading the state of the art, I realized that actually non-expert user can use the document to verify if the topic makes sense or, for example, need further improvements. And with that in idea, I also decided to incorporate in my metric a vector that represents the more relevant documents. So for that reason, here, this metric contains two components. However, we don't know how, and I think it's actually depend on the dataset, how much important are the keywords or how much important are the documents when we measure the similarity between topics. And for that reason, the balance between these two vectors is given by this omega parameter, and it's something that we can further study in future research. Like try to find the best omega score using different datasets.
So one last question about the keywords. So you use word embeddings and you focus on keywords. First, how do you, what type of word embedding are you using?
Okay, I was prepared for that question. I couldn't say before because for the time, but I use Word2Vec. So in this case, the word embedding were training only with the data regarding with the Fable Analytica scandal. Because if we use a general word embedding, for example, from Wikipedia, all the I expect that all the keywords related with privacy are closer. And here I didn't want that because I really want to know the difference between the topics. So for that reason, the first decision was to train only on a specific data set. During this process, I followed a lot of pre-processing tasks. So all the tests to lowercase, remove stores, links, username, identify bigrams, trigrams, and apply lemmatizations. So as you can see here, there are around 70,000 unique words. And it was challenging to find because when we want to create word embeddings, we have to take a decision regarding with the architectures. So it's going to be seaboard or a skigram, or how many dimensions, 50, 100, 300 dimensions, and how many epochs. So in previous research, and actually this appears in the paper that just was accepted, I designed a method to evaluate the different architectures. So I create around 10 or 15 different word embeddings with different configurations. And then I use 18 different evaluation methods of word embeddings. And considering all the results, I found a way to identify the word embedding with the architecture with the best performance. And this is the same word embedding that I am using here. So it was a really rigorous process. And this is another research because then I realized that actually there is not, for example, a consensus regarding what is the best architecture or what is the best evaluation of word embedding methods. So yeah.
Good. And I see that you used bigrams and trigrams. So you treated those as phrases and you had the corresponding embeddings for them, right?
Yeah. And that's really important because here all the time in this specific data set appear Cambridge Analytica together. And that makes sense. That's the name of the company. Or also it can appear data privacy or information privacy, this kind of stuff. I also follow a process to identify because when you want to identify bigrams and trigrams, you have to be really careful regarding with the settings. So I try to find a way to use the default parameters for that case. And it worked. So I made also an inspection of the results, and I saw how Cambridge Analytica appeared together, and Mark Zuckerberg is also a bigram in this case that appeared together and was captured by the word embedding.
Okay. All right, that's all from me for now.
Thank you, Evangelos. Now I will have my own turn to because I am also an evaluator of the exam. About the topic similarity matrix, the question about the intuition that was just formulated by Evangelos, but I have maybe a complementary question. Regarding topic similarity. You have this parameter omega.
Yeah.
In TopicVisExplorer, people can move this and adjust this parameter, looking for the changes in the topic space. My question is, do you think that it is possible to automatically tune the omega parameter, providing an initial guess maybe, or an initial value for this parameter? And if you think that it is possible to tune this parameter, how do you think that it will be the best way to tune this parameter in your topic similarity metric.
So when you set that initial value, do you mean like a seed that comes? Okay. Okay, so yeah, I definitely seen that we can find a way to choose the best omega score. It was actually one of the ideas in the beginning about my thesis, like try to find a way to test that. But if I would do that, then the thesis is like too long. So one way to do that is to using different data sets. And it's something that is actually really popular when we create new algorithms or metrics in NLP. So in this case, not only with the Felipe Analytica dataset, we can use another more popular dataset for that task. So in this case, we should, I think one idea should ask to the user again, identify similarity between topics. So for example, use the second scenario of the TopicVisExplorer and initially set the omega score in a random value and ask to participants to change the parameter until the result is according to their needs. So that's that way to do that. But we can have to do several times with different settings and with different users, controlled by user, controlled by dataset too.
Yeah, but people is in your user study. People moved this parameter in TopicVisExplorer. Do you have a clear idea about what people is looking for when they are trying to adjust this parameter?
Okay, it is interesting because I actually evaluate if the results of the match between topics change by checking by the omega score. So I evaluate, for example, if a higher omega score or a lower omega score impacts the performance or error rate, and I couldn't find the results. And my hypothesis that maybe this is the data set, because at the end, all the topics are related with similar data privacy issue, and it could be a reason, but it's something that I cannot say that is totally true because I would like to check again. And also, what's happening here is, for example, in the first scenario, the proposal of the first scenario the user study was to ask the user to identify split topics and merge topics. So I didn't ask the user to change the omega score. And actually, most people didn't do that. So I think that it's something that, well, I imagine that when they when they conduct when they participate in the study, they saw a lot of different buttons and a lot of several slider and parameters, and it can be really overwhelming. So for that reason, I think that they didn't change because I didn't ask to them, and for them, they actually think they trust in the visualization a lot. Like if they see that a slider is set in a specific value, and they don't think that they need to change that. And in the case of in the second scenario, the omega score were randomly assigned. So every time that a user visit this website, the omega score was different, and I asked them to adjust to their needs. But again, I couldn't find a pattern. Like some people use a higher omega score, or some people use a lower omega score. And that was interesting because I also, in the tutorial, I explained how this omega score works in more no technical words. So I said that when we have a lower omega score, we are going to give more importance to the more relevant keywords. And when we have a higher omega score, we're going to assign more relevance to the most relevant documents. And one of the reasons that maybe they are not too different. So as you can see here in this interaction, in the first scenario, we change the omega score, but the results do not change significantly. there are no a huge amount of difference. So for that reason, it could be interesting to tell with a different data set. For example, if we use a data set regarding with the New York Times articles, so in that case, we're going to have topics related with economics, sports, I don't know, fashion, and I expect that in that case, the result could be different.
But in summary, there are no very clear patterns.
No,
People
for this data set, no. So it is
the omega parameter. Why I am so interested in this aspect of your thesis, because you have this tool that can be useful not only for the end user, it could be also useful to identify patterns where which kind of patterns people use to split topics, which kind of patterns people use to merge topics. If you can identify these patterns, you can use these patterns into your algorithms. And maybe you can make some kind of human-inspired topic model, trying to mimic what your users are trying to do in your tool. Did you find some patterns in topic splitting or topic merging operations in your tool?
so okay. This part is something that I did like not for my thesis, but for future research, and because also in the user study, I use website to collect data regarding with the patterns of the clicking and mouse over. The movement of the mouse. And for example, there is a heat map, and when you can see that in the first scenario, the user focus a lot in the documents. So you can see like they are like reading all the documents line by lines, moving the mouse, and that was really curious because they give me an insight that actually they're trying to do their best when interpreting topics, and while finding the and trying to improve the initial topic model. So regarding with the topic splitting and topic merging, I evaluate first if there were any different regarding with one, if maybe for example, if one operation is preferred more than other. And no, I didn't find difference regarding with that. So the number of people that, the number of merge and number of splitting per user did not differ. And also I had to say that for the user study, many people and most of them only did the less required. So in the first scenario, I asked to them at least to perform one topic splitting and at least to perform one topic merging. And many people did only one and one. Only a few, and I can say actually there are outliers of users who spend more time in this user scenario, and they apply more than one or more than two operations. And also I also identified that the users sometimes try different approaches. So in the first layout, it has 3 buttons, sorry, 4 more buttons. So the user can merge topic, split topics, and here the user can also undo the operation. And that was really important because something about visualization tools is that we have to allow to the user make mistakes. And also because sometimes the algorithms are not perfect and we try our best to improve that, but maybe the result of a topic splitting are not the best, so the user can undo the operation. And it's something that some people did that. And these are the things that happen. Like in overall, there is no preference for topic splitting, for topic merging. The user study participant did, most of the people did only what it was required to do, one topic merging and one topic splitting. They inspect the document to perform the operation, so the heat map show the movement of the mouse over those documents. And that's it.
But maybe you can identify the patterns by mining the logs of your service. If you are recording the actions and the interactions of users with your tool, you can then mine the logs just to try to find the patterns. These patterns can be very useful for algorithms, not only for people, for algorithms.
Yeah, just to say, because I wanted to check that if the topic coherence score were different in the experimental group and Bessel group, and then I focus on the experimental group only, and I also evaluate, for example, if the number of operation, the number of merge or the number of splitting impacts the coherence, and I didn't find that. So it's a challenging. It was really challenging because actually when I tell this story is when you conduct a user study, the participants do not behave as you expected. So it's something that you learn a lot about them. But yeah, I agree. Like it could be really interesting to speak more in details, specific logs or specific interactions or patterns of actions to see how we can do this operation more automatic.
Mhm. I guess that there is a relation between your user-oriented solution to split topics based on TopicVisExplorer and the algorithm hierarchical Dirichlet processes that is focused on the same idea, that you don't have an initial or a static number of topics. Instead of this, you have a variable number of topics that is inferred using topic splitting. Maybe you can review this and some ideas that you can identify using your logs or the patterns that your users are releasing can be used then into a hierarchical Dirichlet inspired topic model, because the problem is the same: how to refine a topic to provide more valuable information to the end user. The idea is the same, but the difference is that hierarchical Dirichlet process perform this in an automatic manner. Now, a final question is the following. Some more general question. What was the most difficult part of your work?
Oh, there are many. So to be honest, at the beginning, when I started this project, I didn't know anything about D3JS, and I spent a lot of time trying to deal with that, especially because, as you can see here, this layout is adapted from a previous one. The tool is LDABs. So I took that code and then I tried to improve that and adjust it to my needs. And when you try to modify code that other people wrote, it's really challenging because, for example, this code wasn't prepared to allow topic splitting or topic merging, so that took a lot of time trying to figure out. And then I learned about that, and for the second layout, actually, I did it from scratch, and it was much faster. So that was an issue. Other problem that I faced was regarding about how to conduct the user study, because in the beginning, well, we know everybody here know about COVID, so with the restriction, I couldn't do in person. In the beginning, I tried to do like in online sessions, so in meetings one-on-one, but I realized that I spent more than 25 minutes trying to explain my tool to the participants. And as you can see here, I actually around 90 individuals participating of the user study. So to deal with that problem, what's happening here is that actually people can access to the platform right now. And when they can access, they had this tutorial, which was a way to actually explain what is topic modeling and how each component works. So that was good. But also, conducting the user study online is challenging because these algorithms that are running in the background are really expensive. So the topic splitting and topic merging require a lot of calculation. And here, this tool is in a server. So I need to use the RAM or the CPU, and I didn't know how many people are going to connect at the same time. So I need to also deal with this, with these kind of things. And also, it was difficult to try to identify the patterns or get the explanation about my results, because as I said before, I had an initial hypothesis. So I thought that it was really straightforward to test it. And then I realized that, okay, I didn't find difference between the baseline and experimental group in the first scenario. So what is happening? And try to find what is happening, it was challenging. It required a lot of time. So yeah, it's nice because I learned a lot during the process. But yeah, user-centered design is challenging because for many things that can happen.
Mm-hmm.
Humans are complicated.
Yeah, maybe more than computers.
Yeah.
Okay, thank you, Felipe. Now we will have the questions from the advisor of the thesis, Professor Claudia Lopez.
Okay, thank you, Felipe, for that presentation. So I'm gonna go back to the motivation and what you said at the very beginning, that something like similarity metrics that are based on keywords have some problems. And those were that they basically could provide poor results. Well, oh, something happened here in my computer and you disappeared. Can you hear me?
Yeah, I can hear you. I can hear you. Can you see the slides?
Yeah, I can. So basically your statement is something like current similarity metrics are not good enough because they perform poorly if the topics are too generic, poorly connected, or they don't provide enough information. So you follow that and say, well, the similarity metrics should consider the documents, right? But then as your study sort of like follow up on that idea, you didn't actually find differences when people use the metrics or try to compare using your metric, right? And I want to understand what are your thoughts about how this basic idea, like the intuitive idea behind, or if you have information about documents, the similarity metric should work better. Eventually, sort of, it became so difficult to find the effect of that in the users, in the user behavior. And I want to know your thoughts about why could that have happened? What are the characteristics that you think should be considered in the following studies to try to like pick what's going on there?
Okay. So I still think that actually is current future topic similarity metric should consider the more relevant documents too, because when we saw the document or when we analyze the document, we can get insight about the context. So I like this slide because here actually we have a keyword, the keyword Facebook. The keyword Facebook appeared a lot, so you can say that maybe it's a keyword or not. It depends of the processing steps. But when a user have to deal with this information or with this kind of keywords, they use the document panel that appeared in the first scenario. And I know because I saw in the using Hotjar, that is a tool that allow me to track the movement of the mouse, but also because I had some informal interviews with user study participants, and they told me like, "Hey, this topic was really difficult to find the meaning because the keywords didn't make any sense." And one way to help users to identify the meaning of the topics is reading the documents. And this is something that we can do like manually. And it's something that in my past I also did when we published the paper regarding with global reactions and chemical analytica scandal. So the problem is why the metrics are only based on only the more relevant keywords. And that was interesting to see that nobody did that. And I am really happy that actually here in my user study, I evaluate, and actually I can say that for this data set, the number of mistaken matches were lower in people who use this metric. So I can say that we achieve more insights, or in some way improve in the results. Maybe it's not perfect, and I can say that definitely it's not perfect. There are future improvements that we can do in the future. There are future things that we can do, but it can help. And I think I forgot the other part of the question, but yeah, can you repeat the part?
I want to know, like, what could have affected the results if we believe that the metrics, the similarity metrics, the new similarity metrics are better. What other aspects could have confounded the result and eventually did not eventually find the things that you found, right? Like that there were no difference between the two conditions. In some things, right? I know that there are differences in the amount of errors, but it did not help them to improve the coherence, so enough to be significant.
Okay, so so in the past, there are different topic similarity metrics, and here you can see a list of some of them. And the last one, the word embedding based metric, was proposed on 2019, and they performed a user study. They performed a user study using people from amateur to evaluate which of these metrics achieved a better performance, and then found that actually topic similarity metric can benefit of word embedding to perform this task. So for that reason, I saw that, okay, word embedding are useful and can provide and can help the user to identify similarity between topics. But the problem, as I said before, this metric is asymmetric. So for that reason, the idea is to propose a new one. But yeah, the results maybe not were always perfect. So I am curious about the data set because I think that I can't make it would be nice, and I think it's necessary to also evaluate this metric with other data sets, and that are more popular, or they are more with a broader number of topics, or with different, like, I mean, I don't want to say topics, but with more different meanings. So here, all the topics actually are really close. And that's an issue that it could affect the results. So maybe actually my initial idea is that, okay, documents help a lot. Here it doesn't do that because maybe the keywords and documents are not too much different. Maybe even the word embedding could affect because the number of keywords is small. And maybe we need to train a word embedding with a higher number of documents, like I use a Wikipedia word embedding. So it's something that it needs further discussion, and it is intriguing. But my first thing that I will do is do the same topic similarity metric as I propose here, and perform a study with other data sets. So another way to do that, as Professor Marcelo asked me before, another way to do that is using mTurk. So in this case, they show 3 different topics, and they ask to the user to detect the outlier, which is the topic that actually are more different than the other 2. And this is a way that I can test my metric with other non-spec user in maybe in a different way. And I would like to see if the results change in that case or not. So yeah, the topic coherence didn't change. The topic coherent reported by user didn't change. But also it's important to say that that was the score reported by users. But when we think about the automatic coherence, and there are several metrics to do that, we can see that actually some people improve the results. So yeah, it's people achieve a better result, people achieve a lower results. And I don't believe that actually is only regarding with the metric. I think that actually people make mistake because it was their first time using topic model visualization tool to do something in a realistic scenario. So I think that if we help to the users a little bit more and explain and do more practice with them, maybe more people are going to achieve better results or improve the model.
Excellent. So I get the idea that it could be like how related or how coherent maybe is the data set, and something about the users and their own experience dealing with these topics, right?
Yeah, one sec. So actually here in the visualization, you can see that so topics that are similar appear closer. And you can see that there is one that is kind of a liar or is really distant. And this is a topic that is related with big data and artificial intelligence. So when I see the results, for me, it makes sense. It really makes sense. Like I can see that, okay, this topic is different than other because the keywords are different. And that's happened with different omega parameters. So I can say that when we focus on the more relevant keywords or the more relevant documents, or with that topic appear really distant between the others. So for that reason, I think that the metric works.
Okay, so here we will have another factor, which is like how related. So one thing is how coherent they are. The other one is how related they are to other topics that are in the same data set.
Yeah, and just to say something, I just remember something that Professor Marcelo asked me, like find a pattern here. And actually people trying to, when I asked to merge a topic, they merge topic that appear closer. So here you can see that two topics are closer, so for that reason they do that. And no one apply a splitting or merge operation over the topic that appear here, the big data and artificial intelligence topics, and it's because also appear far away of the other. So I think that people trust in these tools, and it's something that we have to be. I mean, I like that, but also that means that we have to be. We are responsible of that. Like we have to design very good tool because people are going to trust in those to perform their task.
Great. So my next question is gonna build a little bit from upon Marcelo's question. It's so if we wanted to learn about the user's behavior in trying to deal with topic models, and if we had to create a new task, and the task of saying use one merge and one split is a bad task, or apparently it's not good enough because people just basically do the one task and that's it. What do you think would be a good scenario or a good idea of a user task to be able to find those patterns?
To find the patterns about merge and splitting, you mean?
Yeah, like what you tried was saying, at least use it once. And people said, well, I'm going to use it once. What you should do, or what would you recommend someone to do to allow people or to incentivize people to do a little bit more and try to find how they merge and split things?
Yeah. Yeah, it is interesting. Like, maybe it's not the best answer, but for example, I think that the problem, why did people, I was thinking like, why the people only did just the minimum, like why only one split and one merge? So I think, yeah, it requires a lot of time to training, and also there are two scenarios. So the idea is to complete this task during 1 hour. So I think that maybe the way that this user study was conducted was too much for them. Like maybe I would just focus on the first one and then use another participant to do the second one. But that's one thing. Also, for example, maybe inspecting the topics in this way require more time. So as Professor Marcelo said, we can use, for example, replace the central panel via tree or via hierarchical clustering. And the user can see, for example, in one way, what merge or splitting are recommended. Like if we have a tree, we can do some cuts. And then we can, in that way, we are doing a kind of merge because we are getting from two specific topics a higher level of that. And also we can maybe expect a specific topic in that tree and then perform more details in that. So maybe when the user just click in this tree, applying code and match, it could be faster. And it's a way that it would be allow me to see how many merge or how many splitting are conducted. Because yeah, in this case, the splitting operation requires that the user read the document, but they spend some time doing that. And also it is interesting about users, because some people read, for example, 20 documents and they categorize 20 documents. Other people categorize 10 documents. Other people categorize 30. But I have people that categorize hundreds of documents, and it wasn't expected that. And when I saw the results, I was highly surprised because that person put a lot of effort, and if that person is seeing this, I have to say thank you. But it's something that happened, and the idea is actually try to find ways that require less effort from user to apply this topic merging and topic splitting. So that could be a way. And I think that should be the issue. Like that could be a user study task, like change maybe the central panel and allow the user to use a tree and do some cuts to merge topics and also inspect the topics and split them automatically. So we do automatically maybe require less time for users, and we can see, okay, they did 7 times or 10 times. The other thing that I'm thinking, I don't have any idea about other way, because it is expensive, and actually here there are only 6 topics. But for example, when we apply topic modeling in NLP papers, sometimes they talk about 50 topics, 60 topics, and I can't allow to the user spend a lot of time. And myself, when I did this work manually, I spent at least one afternoon or maybe one day evaluating the topics with details, reading all the document, all the keywords. And I am really happy that actually here, the people, most of the people complete both user study scenarios in less than 1 hour or 1 hour and 10, something like that. So yeah, so that's it.
Okay, that would bring me to my last question, which is, you proposed merging and a split mechanism, and I think the split mechanism is particularly novel. And I want to know how sensitive are the results to the number of documents that users decide to associate to each component. Was that clear? Right.
Not entirely. Can you?
Yeah, I understand that your split mechanism is new, right?
Yeah.
Then I want to know how the performance of that splitting, like, I don't know, maybe the coherence of the topics at the end, or some sort of measure of the quality of the resulting topics is affected by the number of documents that people decide to connect to each topic, because I could imagine that could also be a factor in the final coherence of the topics.
Yeah. I didn't find it was surprising, and also for that reason it was challenging, because analyze the results. I was expecting more significant results between the groups, and you also so I evaluate how many documents, how the number of categorized documents impacts the topic coherence of the topics, and I didn't find that. So it's surprising, because the person that actually spent a lot of time categorizing 100 documents didn't achieve a higher or lower coherence than the person that categorized 10 of them. But there is a reason because of that, because in this model view, the documents are sorted according to the contribution of the topics. So actually, the documents that appear in the beginning are more related with the topics. So the user spend more time here categorizing the first 10 documents, it will give me more insight about the relationship or the new subtopic that they want to create, instead of focusing on, for example, in the document that are in the position, I don't know, 1000 or something, because they are not very related and they do not provide many information about how to do that. And also because word embeddings are powerful. So if for that reason, I really like that. We can get insights about the semantics of the keywords, about how keywords are related with another one. And I think that they made a great job doing that. And for that reason, it was just enough to categorize 10 documents to get the same result that someone that spent a lot of time categorizing 100. So it's something good. Like we don't require a lot of mental demand to perform the operation and have a score. And also, I have to be honest. For me, it is also important to see that they applied topic splitting, they applied topic merging, and they left those results. Always, the user could, always it was allowed the user to undo the operation, and it was fine. So if the user didn't like the result, they can undo and get the initial topic model. And they did do that. So for me, actually, it made me feel confident or like tranquil that they really adjust their model to their needs, and that's important. Like allow to put the semantics or knowledge, the knowledge of humans to improve one automatic task. Yeah.
Great, thank you. I'm done with my questions.
Okay, thank you, Claudia. Now we have the opportunity to formulate some additional query, some additional question. Evangelos, do you have an additional question?
Yes, thank you. Okay, so I have two general questions. One question is, what is your ultimate conclusion from your user study? Does your system offer advantages over the baselines?
Yeah, I mean, there is no topic modeling visualization tool that allow to perform these two scenarios. The further layout that allow to people to identify that or get a global view of topics, and also apply splitting and merging, and at the same time can allow to the user to compare two data sets. There is no one. So actually, then I realized that I could focus on one scenario, and then I can like focus more on that, and then get a paper of that. So this is something new. Like there is just one tool to do two different things. Also, there is no any LDA topic modeling visualization tool that allow to refine the topics, and this is important because so most of the tools that exist nowadays use hierarchical topic modeling to split or merge topics, but LDA is really popular even today. And not only people from computer science use it, also people from sociology and other areas too. So for me, it is interesting that they can still use an algorithm that they know with a visualization that I hope it can be kind of easy to learn, and that is another advantage. Also, another advantage, as I said before, I saw here that even though I didn't find difference between the self-reported coherence between the Relevance and experimental group, users identify topics that need further refinements, and also they adjust the model to the needs. For that reason, they left those results at the end. And also, I saw that they could analyze a large scale data set. So here we're talking about hundreds of thousands of tweets, and they didn't know anything about the data set before. They know about privacy and they know terms related with computer science and big data, but this data set was new and was a huge data set. So it made me feel, I am glad that they could identify the topics. And manually, I also inspect the names, because something that I also ask to the user is identify the names of the topics, and it makes sense. It made a lot of sense. And comparing with that topic similarity baseline, the results showed that they could find similar topics that are similar between them. It's not perfect, but it helps, especially when we don't want to do mistakes. So these are kind of the contributions to work. Like, and I really hope to release, because something that happened with this visualization or with these tools is that most of them ended with a paper, and that's it. And I think it's a problem of doing research. Like, okay, we do a lot of work in a visualization tool, then we publish the paper, and then when someone wants to use the tool, the code is not working anymore, or is not updated, and other stuff. So I want to release this tool, and already now actually it's possible to use this as a library, and for example, run all this visualization in a Jupyter notebook. So I am working in the integration, and I hope people can use it.
Great. So two more detailed questions now, and that's the end for me. You have a constant 0.6 in your topic similarity equation. So where did that 0.6 come from?
Yeah, I was expecting that question here. Okay, so yeah, that 0.6 is actually the value of another parameter, a lambda. So this is a paper that, so the problem here is that usually in topic modeling algorithms sorted the keyword regarding with their frequency, but a problem of that sometimes the more relevant keywords, if they are too frequent, they do not provide enough information. So in this paper, they propose a metric. The name is relevance, or the relevance score, and that considers the frequency of the keyword and also how exclusive the keyword is, with a question that appears here. And this equation, yeah, so this equation is actually a balance between the frequency of the term and their exclusivity, that they call it lift. And then they have a parameter, this lambda. So they perform a user study where they found that the best value or the value that adjusts better to user criteria is 0.6. So for that reason, I left that value for my metric, because otherwise it should be a lot of things to change for the user. So the user only changed the omega score, but the relevance score was this one, 0.6, because a user study support that value.
Okay, so this 0.6 in the formula for topic similarity comes from this reason.
Yeah, for this paper where they explore different values, and they found that 0.6 is the balance, and that makes.
All right. And another choice that you made is to choose number of topics equal to 6. So do you think that choosing a different number of topics would have a major impact in the results?
Yeah, I was expecting that question too. So thank you. Yeah, one of the problems is actually the number of topics. So in LDA, we have to set by ourselves. So a short number of topics actually can mix some distributions. So the topics maybe are too broad. And if we use a large number of topics, maybe the topics are too specific, so actually do not provide enough information, or they are not adjust to the user needs. So for that reason, I took the European, I create several LDA topic models with number of topic 1, 2, 3, 4, 5, 6, until 15. Why no more? Because I want to perform the user study, and I know for sure that people can spend more time expecting each topic, because they had to expect or have an idea about that. And 16 topics or more is too much. And then I use a coherence metric that based on the co-occurrence of terms, identified how good is the topic model in general. And I found that actually for between more than 5 and 6 topics, the coherence score is higher than 0.4, and so we can use one of them. A lower number is too bad because it's not the coherence is not it is not good. So yeah, the question is now how many topics? 6, 9, 11, 15. So I can do a pilot user study, and then I was a one-to-one meeting, and I tried different settings, for example, the number of topics, and I realized that actually 6 topics was enough, because otherwise the user spent more time, more than 1 hour, conducting the user study. So I didn't want that. I wanted that all the 2 scenarios, the user finish in around 1 hour and no more time. So that made me, that was the decision that I took.
Great. Thank you. And that's it from me.
Thank you, Evangelos. I don't have more questions, Felipe. The advisor, Professor Claudia, do you have more questions?
I will actually add one question given this chart. So I know that the differences are not significant, but I see that 6 is a little bit lower than 5 and 7. Did people move to 5 or 7 like in different ways when like the final topic model that they submitted? Is it more often that is 7 or more often that is 6? Or...
Yeah, that was surprising because some people moved to 5. I think 1 in 4, and other people ended with 8, but most of the people ended with 6 and 7. so they made me realize like they actually merged one topic and then split one other. So at the end, ended with 6 topics.
I see. Yeah. Okay. Yeah, that was my last question. Just wondering.
Thank you.
Thank you.
Christian, do we have some questions from the audience via streaming? Christian, ¿tenemos algunas preguntas de la audiencia desde el streaming?
No, profesor, ninguna.
Ok, entonces, so with this, we end the second part. We finished the second part of the exam. And now we will go to qualify this exam. And so Felipe, please stay here in a separate room. Cristian, por favor, enviar a Felipe a una sala separada para que nosotros nos quedemos deliberando, y por favor, si puede interrumpir el streaming. We will be back again in a few minutes after the qualification to communicate the result of the exam. So please thank you to the audience, to the people that is connected to this exam. We will be back in a few minutes. Scan assignment. Don't worry about this. Okay, so we are back again. Now we need Felipe. Hi, Felipe.
Hello. Can you hear me, right?
Yeah. Yes.
Okay.
Okay, so Felipe, the committee is very happy with your work. We have a very good opinion about your work, about your oral exam, about your writing document, the writing part of your thesis. Your document is a very good level document to opt to this degree, and there are clear contributions. There are also clear findings that can be used to and extended in future work. So we are happy, and we want to grade your work with 100, both items. So congratulations, Felipe. From now you are a master of informatic engineering.
Yeah, finally.
Finally, yeah.
Yeah, finally. I can now apply for the PhD. No, I have to say thank you to everyone. First, the participants. So just to I don't want to forget that because I said in the user study that eventually I will do a raffle. So I want to share my screen because this is a perfect moment and some of them are actually watching the streaming. Can you see my screen, right?
Yes.
Okay, so this is the list of all the participants. They appear their emails, but of course, for privacy issues, I try to modify some of them. And and yeah, so yeah, there are a lot of people that want to get the 3 Amazon gift cards. So I will use this website. I know that this is weird for a thesis defense, but it is important. And in this website, I will put their names, and I will shuffle the names sometimes. And here there are how many winners? There are 3 winners. So yeah, can you still see my screen, right?
Yes.
Okay, the website, right? Yeah, not the Excel. Okay, so now let's pick the winners. Okay, yeah, so we have the winners. Yeah, I don't know who, I will check later. Okay, so yeah, everyone know that it was clean and everything. And yeah, congratulations to them. And yeah, now, yeah, thank you to everybody, to the participants. It was difficult with COVID, and thank to all of you, to all the professors. I know that it was a lot of time trying to solve all these problems that I must face when I was working on the thesis. So thank you for all your support. And for the master, of course, and I mean, I am now in Canada, and it's just because of the master, and I am from the Dalhousie University because with the ILAB program helped me a lot, and especially in COVID. So no, I am really happy, and I want to thanks to everybody here, and yeah, my family too, and friends too. So yeah.
Okay, Felipe. So now you will need to maybe to follow in the studies, yeah, your PhD. So we are very proud of your the continuation of the studies in Canada, and we will have, of course, some good news from Canada, from you. So we will be expecting your new papers and your
yeah. So actually, I will continue working on topic modeling visualization tools. So that would be interesting. So for that reason, this thesis is
it's a very good topic.
Yeah.
And give my regards to Giuseppe when you see him.
Yeah, I hope he's maybe watching the stream. So yeah, he should be my supervisor. So yeah, he actually made part of the related work that I show here. So yeah, it's interesting how everything works. So yeah, that's it. So one question now, I will receive some comments that I need to fix.
Yes,
or
you will receive the reports of the committee, and you will have a few weeks to incorporate these comments in your final document.
Okay, perfect.
So please pay attention to your email.
Yeah,
don't forget the USM email.
Yeah.
You still need to submit a few things.
The one that you sent today?
No, I mean the emails from our university.
Yeah, no, I check it. Yeah, I check it.
So I would like also to congratulate Professor Claudia Lopez. You are the first student in the program from Claudia.
Yeah, it was a long way, but we made really great things. So, I mean, I think it wasn't expected to publish so many papers. And in the beginning, when I met Claudia, actually, I wanted to take a different path, like do some management or work like a project manager. And now I am here. So things change. So yeah, Claudia, you know that I'm really grateful for all your support.
I know. I'm glad. I'm very proud that you finally defended. I knew that you would defend. It was just a matter of time. But now it's a great moment to defend. You are starting a new life and a new excellent moment in life, which is the PhD life. Enjoy that, but submit the final documents of your master. Please do not forget.
No, I actually need the degree certificate for UBC. So they are asking for that. Yeah, I will do ASAP. ASAP.
Wonderful.
Okay, so we are ready.
We are ready and on time.
Congratulations again.
Thank you so much, Professor.
Thank you
so
to the
much.
audience and to the people that attended this exam, and we will see you in the next exam in the near future. Thank you, Evangelos. Thank you, Claudia, and congratulations, Felipe.
Thank you. Bye-bye, everyone.
See you.
Bye.
Bye-bye.
Bye, Marcelo.